Okay, so we're going to look at a few problems. I think, Nikki, you said number 7, number 23, and number 24. Is that right?
Yes.
Okay. All right, so we're going to look at this, and I'm going to share the screen to kind of show you what we're looking at here. Okay, so I'm going to go back up here to number 7. I'm going to move this over here. So number 7, the question was, which radiation travels faster, microwave radiation or gamma radiation? This is a trick question. Do you have any idea? Do you have a guess?
No, I thought it was gamma ray, but I guess not.
No, it's yeah, it's totally a trick question, and I promise this will be on the test. I want you guys to remember that all radiation, regardless of what it is, travels at the same speed, and we call that the speed of light. So all radiation travels at the same speed. It doesn't really matter whether it's gamma or microwave or visible light or whatever. They all travel at the speed of light, which normally we measure as like 3.00 times 10 to the 8th meters per second. But like this week, we've been dealing, and last week, we've been dealing with space velocity. So we measure that, and we use 3.00 times 10 to the 5th kilometers per second, because since you're dealing with bigger lengths, we use kilometers. Okay. All right. Does that make sense? But they all travel at the same pace. All light.
Yeah.
All radiation. Yeah. Totally a trick question. Yeah. I'm going to put that one on the test. I promise. The rest of these, did you find these okay, like in the reading question guide? And did you just look at old homework to get those?
I mean, I knew most of them.
Yeah, good. Okay. All right. Hey, let's look at number 23, and then we'll do number 24, but I'm going to probably do that one on the board. Okay. All right. So number 23, how is redshift used to find distance and velocity of distant galaxies? Now, here's how this is going to work. I simply want to know that you understand redshift is specific to whatever galaxy you're talking about, or it's specific to a star. Redshift will change depending on whatever galaxy or star that you're looking for. But then you just use these formulas that are behind me here to find distance and velocity. So redshift has to be used to find velocity first, and then from that you can use it to find distance. So redshift could be used to find distance. And for an example, like if you wanted to kind of rearrange these formulas as well, if you didn't have velocity down here, but you had like a distance, you could totally just use z times c right here and make a brand new formula. You could use redshift right here. And do you see what I'm saying?
Yeah.
Yeah. So it's like if I didn't give you the speed or the velocity of a galaxy, if we didn't have the velocity, but you knew the redshift, and we know speed of light, it's a constant, you could take this part and plug it in right here instead and solve to find distance. So that's how redshift can be used. So you can use it to find velocity, or you can plug it in where the velocity goes and solve to find distance. Okay. All right. Next, the next one that we're going to look at, let's look at number 24. Okay. So I'm going to unplug you. My kids are at the table working too. So anyways, everybody, and Brian is trying to train somebody at JB Hunt, like online. So we're all talking at the same time. Anyways, but I'm going to take this out and we'll look at that last problem. Okay. So here we go. Number 24. If a galaxy is 1.98 times 10 to the 7th light years away, what's its recessional velocity? Okay, so we know we're looking for V, right? Recessional velocity. But what we do know is that it is 1.98 7th away. So do you remember what is its value? What is light years? What's that the unit for? Do you know?
No, I cannot remember.
It is distance. I'm afraid there's a big glare there. Anyways, it's distance. This is so this is distance. Okay. So what I'm going to do is I'm going to take this distance and I'm looking for a velocity. So I know the formula has v and it has distance in it. So I'm going to use this formula right here, my distance formula. Okay. I'm going to take that number and plug it in. I'm going to say 1.98 times 10 to the 7th light year is equal to, I'm trying to find my v velocity, divided by Hubble's constant. And can you see this okay? What I'm writing?
Yeah.
Okay. So here's my d, here's my distance. I'm looking for velocity and I'm going to plug in Hubble's constant. Hubble's constant is 3 times 10 to the negative 5th, and that's kilometers per second per light year. Okay? And now at this point, we're just gonna.
Is that 2.31?
Yeah, it's 2.31 times
Okay.
10 to the negative 5th. Times 10 to the negative 5th. Okay. And then you'll grab your handy dandy calculator.
Yep, that I don't have.
To find v, I'm just going to cross multiply both to find v. Okay, and have you got your calculator? Did you find this out?
I have my calculator now.
Well, and just like you might want to double check my math. So, anyways, this is what I got. I got 457.4. I rounded, and the units that I'm left with that per second would cancel out. Or sorry, not cancel out. Sorry about that. Light years cancels out. And so what we're left with is kilometers per second. So velocity is over here in kilometers per second.
Yeah, that's what I got.
But yeah. All right. But yeah, that's what you would do on that. Okay. So there's those 3 problems. I'm going to go ahead and stop recording on this.
Okay.